Today's question is about indices. Solve for x in the equation 5 raised to 3x plus 3 plus 5 raised to 3x minus 1 is equal to 125.2. Applying the laws of indices, considering the first part of this equation, 5 raised to 3x plus 3 can be expressed as 5 raised to 3x times 5 raised to 3. Now addition of the indices here implies multiplication. So 5 raised to 3x times 5 raised to 3. The bases here are the same. And then for the second part, subtraction of the indices implies division. So we're going to add 5 raised to 3x divided by 5 raised to 1. Now the right hand side remains the way it is. From here, we know that 5 raised to 3 is 125. So we can rewrite this equation as 5 raised to 3x times 125. And then for the next part, we'll add 5 raised to 3x divided by 5 raised to 1. So the division can change into multiplication so that we have 5 raised to 3x times the reciprocal of this. So we're going to have 5 raised to 3x times 1 over 5. The right hand side remains the way it is. So at this point, we can note that 5 raised to 3x is common to this term and this term. So having realized that, we can let 5 raised to 3x be some letter. So we are going to do substitution. So let 5 raised to 3x be, for example, t. And that means our equation is going to become, so this first part becomes 125t. So we have 125t. And then for the next part, we have t times 1 over 5. That is t over 5. So we're going to have plus t over 5. And then the right hand side remains 125.2, just as we have here. So for this equation, we are going to multiply all through by 5, which is the LCM, in order to eliminate this fraction. So multiplying all through by 5. When we multiply the left hand side, we have 625t plus t. That is 125t times 5. That is 625t. And then t over 5 times 5 becomes t. The right hand side, 125.2 times 5. That should give us 626. Now the left hand side, when you add, we get 626t, and the right hand side is 626. So dividing both sides by 626, we realize that t is 1. At this point, 5 raised to 3x is equal to t will resurface. Remember, we had let t to be 5 raised to 3x. So instead of saying t is equal to 1, we can say 5 raised to 3x is equal to 1. We also need to recall that a number raised to 0 is 1. So this equation here can be expressed as 5 raised to 3x is equal to 5 raised to 0. Remember, 5 raised to 0 is 1. Now we need to take note of the choice of the base here. We are having the base as 5 because the base for the left hand side is also 5. So we're doing that so that in the next step, when we drop 5, we'll be able to equate the powers. 3x is equal to 0. So we're going to say 3x is equal to 0, and therefore x becomes 0. And that is the solution to the problem as had been desired. Thank you for watching.